Well, we can't plug in 0, obviously. So I guess we'd have to do something similar where we'd have to try to get the conjugate. Or no, we can't even get the conjugate in this case. I'm not sure where to start with this one. Where do we plug in?
Well, so what's something you have to deal with first?
Yeah, we have to deal with that absolute value first.
Right. Okay. So how do you deal with that?
So it's basically just negative x in parentheses, like a negative outside parentheses, and then x
Yeah. How do you know that?
function because it's turning. Well, actually, it wouldn't be that exactly. Oh, we turn into a piecewise first.
Yeah, we could. Yeah. So that's we can do that first. So what's the
The
first
first piece
piece?
is if it's greater than 0, then it's just the normal 1 over x minus 1 over x. And if it's less than 0, then it's just 1 over x minus 1 over negative x. Oh, wait.
Okay. Yeah, that's right.
I'm just thinking that no matter what x we plug in, it'll always be 0.
Yeah, for the first
Right?
one, right?
Even for the second one, though, because if we plug in a negative x and then we subtract 1 over the positive x, wouldn't that make it 0 as well?
Well, so if it's the second one, what does that simplify to?
1 plus 1 over x? 1 over x plus 1 over x?
1 over x, yeah, 1 over x plus 1 over x. It's just how do you, what if you combine those, what do you got?
2 over 2.
Yeah.
Wait, yeah, 2 over x.
2 over x, right? And then what, so when do these functions apply?
When our x is less than 0.
For which one?
For the bottom one.
Okay, yeah, x is less than
and
0.
Greater than or equal to for the top.
Okay, yeah. Then I think 0. I guess 0, x can't, you can't say
Yeah,
equal to because
so it'd
x
be
can't
greater
be
than
0.
0, yeah.
X can't equal 0 overall. Right, because you can't plug that in no matter what. Okay. So then, okay, so then what do we, so then what's the limit that we're actually looking at? Limit of what function?
The bottom one.
Okay. Okay, so then what do you think this limit is?
Plug in 0, we get 2 over 0, which is undefined. Or rather, does not exist.
Well, so 2 over 0 does actually exist. It's undefined when it's 0 over 0. 2 over 0 does mean something. Do you know what the 2 over x function looks like?
No, I don't.
Yeah, so this function, what's going on is as you get closer, what happens as your denominator gets smaller and smaller? What happens to the overall number?
It gets a lot bigger.
Yeah, it gets bigger, right? And then since it's to the left of 0, that means the number is going to be negative, right? Because we're plugging in negative values for x. If x goes towards negative infinity, what's going on with the overall value?
Oh, it's becoming more positive?
Not more positive. Like if you get a bigger and bigger denominator, right? Like 2 over 1,000. What's happening to the overall?
Oh, it's getting
number?
closer to 0. Oops. Yeah.
Okay, so remember the curve. So as you go towards negative infinity, the curve gets closer and closer to 0, right?
Yeah.
But then what happens is you get closer and closer to x equals 0.
As x is closer to 0, just do the same thing, but on the other side. So like it become closer and closer to 0.
Again, what happens?
It would become closer to positive infinity.
Yeah, and then actually it's negative infinity, right? Because we're dealing with negative numbers. Does that make sense?
Yeah, now it does. Yeah, sorry, I was kind of confused on that.
So this is what 2 over x looks like. At least the left side, the right side looks like that. So then what would you say? How would you answer this question then?
I guess negative infinity in that case on the left.
Infinity, right?